Assalamu alaikum. Hello everyone. Today we're gonna cover Ohm's law. What is the relationship between voltage, current, and resistor? So what you will learn, what is electricity, what is voltage, current, resistor, and Ohm's law, what is resistor in series and in parallel, what is a voltage divider, and what is a digital multimeter. Material list, you're gonna need a 9-volt battery, resistors, jumper wires, light emitting diode, DMM, digital multimeter, and a breadboard. Let's look at this analogy between water pressure and voltage and see what is the common between them. So when current is flowing through a wire, it is the same thing as water is flowing through a water pump or to a hose. So if we put enough pressure on the water pump, we get more water. So the same thing, the current basically. More voltage, more current. But if someone put his hand and try to block that flow of water, of course the water is going to decrease. The same thing for electric circuits. When we have a resistor, it will slow down the flow of the current. So this is the analogy, just to give you an analogy between water pressure and water pump or a water tank, basically with the height, that difference of heights of water in a tank that creates some kind of pressure, or what we call in electricity potential difference. Okay, that amount of charge of electricity in one side more the other side. So let's look at the voltage current in a circuit. So we have a voltage or a battery, a resistor. Let's put a load like maybe an LED, light emitting diode. So if we close the circuit, what happened? The current will flow. The current is going to flow through from a positive side to the negative side, and the light is going to turn on, and this is what we call conventional currents. But actually what's happening, electrons flowing from the negative side to the positive side. Physically, this is what's happening. This is just conventional notation, but the flow of charges of electrons are from negative to positive. So the relationship between current, voltage, and resistor is described by these three nice gentlemen. So voltage is Mr. Yellow is trying to push that pressure, Mr. Current, through the bottle. Mr. Resistor is trying to make his life difficult and squeeze him. So resistor is opposing the flow of the current. So Ohm's law, you will describe basically this relationship between voltage, which is directly proportional to current. The bigger the voltage, the bigger the current, and resistor. So the higher the resistor, the smaller the current. So this is the Ohm's law, the famous Ohm's law formula. And from here you can get resistor is V divided by I, and I is nothing but R divided by V. So this is Ohm's law formula. V stands for volt, that's the units for voltage, and I is intensity, stands for the intensity of currents, and the unit is amps or ampere, and then R is resistor, and this is the Greek symbol omega, which designates ohms basically. Resistor was discovered by a German scientist named George Ohms. So let's see if we can read. Most of resistors, like the one I have here, for example, in my hand, they are made, or all resistors have a color code, just like the one I have right here, okay? So to read the value of This is, for example, a 4-band resistor. It has 4 colors: brown, black, red, and yellow, or gold. It's supposed to be gold. So the first band, you will give you the first digits of the value of the ohm. The second band, which is black in this case, so we have 1, which is brown, the value. The second band, it will give you, since it's a black, it's going to give a second number, which is 0. And the third band is a multiplier. So in our case, red, right here, so we have to multiply by 10 to the power 2, or simply 100. And then the last band, this one here, this is the tolerance. This is basically that error, So we take the value that we get from these 3 bands and multiply, in our case, gold is 5%, so plus or minus 5%, okay? So in this case, we have, as I mentioned, brown is 1, black here is 0, and then we multiply by 100, means adding 2 zeros here, 1 kilo ohm, plus the tolerance of this. So plus we have to multiply by 5%. But this is basically the value of resistance. That's how you calculate. Same way, if you have like 5 band, you will just use the same principle. So in this case here, this one was brown. In this case, let's calculate the value of this resistor. Same way, we're gonna use, instead of 1, now we have in red, so it's gonna be number 2. Black is 0, okay, and then we multiply by 100, which is another red, the third band, and then plus or minus 5%. So this resistor is 2 kilo ohms. So a resistor in series. So let's say we have a 9-volt battery, and we have R1 or resistor 1, and if we connect side by side these resistors, and the other end connect to the positive, this is called circuit resistor in series. They are connected in series, okay? And to calculate the voltage, there's a formula using Ohm's law again. The current times the total resistor equal the voltage. So voltage equal current times total resistor, which is R1 plus R2, R1 plus R2. So this is resistors in series. Let's take an example. So with a 9 volts battery, R1 1 kilo ohm, R2 2 kilo ohms. So let's calculate the current in this situation using Ohm's law. Is the current is nothing but V divided by R1 plus R2. So I equal to V divided by R1 plus R2. Replace the values. You should have 3 milliampere. So that's how using Ohm's law. Okay. Now let's do resistors in parallel. So in parallel, they are not like one by one. I mean, as the diagram indicates, these two are in parallel, and then they are connected just like that to the positive side from here and to the negative side from there. So notice that when we have resistors or circuits in parallel, this case the current is going to split. There is a node here. Part of it is going to go to R1, and the other part is going to go to R2. So really, total, it will be normally I1 plus I2. So I1 plus I2 equal to IT because it's split here, okay? So part of this current is going to go through resistor R1, and the other part is going to go through R2. So in this case, the Ohm's law formula is V always equal current times resistor, but the resistors, total resistance this time, it's 1 over R1 plus 1 over R2. In series, we had R1 plus R2. but in parallel, it's 1 over, okay? And the total current, as I mentioned before, it's I1 plus I2. Voltage divider. So when actually do we need voltage divider? Just in scenario, for example, like when we have like in one of our projects, we were using Arduino, and you know Arduino is a 5-volt device, but we want to interface it with a Bluetooth device which use logic level 3.3 volts. So we really have to reduce the voltage logic level in for Bluetooth. To do that, we use resistors, okay? And then we're gonna basically reduce the amount of voltage dropped at Bluetooth, and that's what that is the what we call kind of voltage divider, okay? So like this scenario here, we have R1 and R2. Let's say we have Arduino which come in with 5 volts, and we want to get out from here 3.3 volts. So to do this, we have to select carefully R1 and plus R1 and R2, okay? And always using Ohm's Law and to really come up with all these formulas. But here is the formula we use for voltage divider. V out, which is here, means voltage dropped at R2, is nothing but the input voltage, which is V in, which is 5 volts, times R2 divided by R1 plus R2, okay? A digital multimeter, or DMM, you know, what is it? So basically, it is very important device. We use it to measure basically voltage, resistor, and currents. We use it for troubleshooting. It is a must-have device when troubleshooting your circuits. So let's say we have R1 and R2, and let's say, as you see, this digital multimeter, we have measurement for ohms, resistors here, amp or ampere, and voltage. So in this scenario, we are trying to measure the resistors resistance around R2, okay? The voltage, if you want to measure the voltage, you move this knob to V here, and then you just measure, for example, voltage drop around here. But if you want to measure currents, this digital meter has to be in series with the circuit to measure the current passing through that circuit, okay? Let's do an exercise now. And let's go to Tinkercad. So Tinkercad is a simulation tool that you use. So let's say we use a breadboard. And we're gonna need a 9-volt battery. Just make it rotated like this. We're gonna need a resistor. This is 1 kilo ohm, that's fine. We're gonna need an LED. And an LED, notice that there is a long leg which is called the anode. That's normally we get the positive side. It's polarized components. And the cathode, which is the shorter leg, that's where we connect it to ground, okay, or negative side. So now we want to connect basically the positive side to resistor, and we move the LED. So we connect it with the resistor, and I'm gonna just make this red since it's positive, and then we connect the other terminal of the LED to the negative side. Just make it look nice. You don't have to. and then you just give it a black color. Okay. So now in this scenario, we have a closed circuit. Okay. We have current flowing from, as I mentioned before, the electrons will flow from negative side from here, and they're gonna try to reach the positive side. Okay, but the current is flowing from positive here, going through the electronic component, which is LED, and coming back to ground here. So if I do simulation, everything is great. Okay, let's see if we take the resistor off. So I'm gonna stop the simulation. We take it out, and we connect directly the positive side to the LED. I'm gonna start simulation. Oh, what happened? We burned it. Current through the LED is 915 milliampere, which is too big for the rated value, which is only 20 milliamp. So that's why we need resistors. Resistors really to reduce the current flowing through components, or also sometimes you want to reduce the voltage drop. So resistors are very important, and Ohm's law, it is very, very important. Thank you, and I'll see you next time. Bye.